Alright, what I'm going to do now is demo a union find implementation just to show you how easy it is to actually implement this. If you haven't done so, you'll want to review the slides or the video recording that goes over the structure itself, just so you can see how that works. But let's go ahead and demonstrate how this works. So I'm going to write a program. First of all, let's go ahead and include vector and IOStream. Okay, and basically the program, it's only going to do two things because I just want to demo it. It will either let us merge two sets, do a union on them, or it will let us find what set an element is a part of. So for now, I'll go ahead and I'll fill in the data structures in a minute, but let's go ahead and implement the part that is used to read in input and actually process it. So I'll create a main function, and I'll have an operation type, which will be one of the options, and I will say, let's just set this equal to 1 initially, and I'll say that the operation is going to be 0 when we're done, just to have an endpoint. So, well, operation is not 0. I'm going to basically keep reading stuff in, and the first thing I'll do is do the same thing here at the end. Okay, so it'd probably be better to do that with a for loop, but whatever, makes sense. So in this case, I'll say if the operation is equal to 1. In this case, I'm going to want to read in a set or an element number and decide what set it's a part of, and the else will be where I want to merge two things. So here I will say I'll read in a second number. So if the operation is 1, this means I want to find the set. So this is the find operation. So I'll call that element A. And I have to actually create A. And then I will say okay, so I'll just have something like that. I'll just say what element it's a part of, and then have the function find that tells me what A is a part of. And likewise, down here, I'll have A and B will be two sets, and I will go ahead and read in A and B if it's operation of type 2. And I will say merge A and B. So I'm going to have a merge routine, or I think we called it union before, but let me just call it merge because that's a little bit easier. And union sets for element A and B. Okay, so, oh, sorry. Okay, so that's going to just be saying each thing that we've done along the way. So that's just the basic structure that we'll have in place there. Okay, so let's go ahead then and actually create the structure that we have. If you remember, we need, for all of the elements, we need a parent array. And so we might want to start out with that, with something like that. So vector of ints. I'll call P for the parent. And actually I didn't do this yet, but let's go ahead and read something in that says how many elements. Okay, so n elements is going to be the very first thing we read in. It's how big of a vector we want for P. And then we will go ahead and initialize our P array. So we will do p.resize, and the elements. So it's going to have however many elements there are, starting with index 0. And if you remember, we need something that's going to give us the maximum size, so the maximum depth. So we will resize that. Okay, so we'll have the same thing here, and this will be, no, sorry, max size. Okay. All right, sorry about that. All right, so we've got our P array, that's going to be the parent, and we've got max size, and we want to go through and just initialize all of this stuff right here at the beginning. So actually, there we go. All right. I don't have anyone here to watch me and tell me that I'm typing things stupidly along the way. So this is going to be, just to put in the comment, this is going to be perform operations. And this is going to be our initialization part. Okay, so after we've resized these, so we have arrays P and max size, each is already of size n elements, we'll create a for loop. So for n I equals 0I less than n elements. Plus, and remember that the parent of every element is just going to be the element itself, and the max size at the very beginning for every element is going to be, we'll say 1. It could be 1 or 0. It doesn't really matter as long as we're consistent. Okay, so so that's the size of each one. We've now initialized everything. So we need 2 routines. One that we need is find. So this is something that's going to return an int, and we'll take find, and it's going to take as input an integer. Let's just call it x. Okay, and the other operation that we have is going to be a merge routine, and it will have 2 integers, x and y. That will be the 2 things that we want to merge along the way. Okay, so let's go ahead and write our find routine first. So find, if you remember, is going to basically recursively go back and update the parents for everything that's there. So we first of all say if the parent of x is equal to x, in other words, if we have reached a root and we're at the parent, well then we're basically done. Okay, so in this case we're basically done, and so we are just going to return x. That's going to be the root of this tree. It's going to be the top element, so we just return x, and otherwise I guess we'll write this as an else. So if that's not the case, you don't have to do an else here, by the way, because it would automatically fall through. Otherwise, we are going to set p of x is going to be find of p of x. Okay, so we are going to find whatever set the parent is in, and then we are going to reset x's parent to be that parent. Okay, so we'll go all the way through, and then finally we will return whatever p of x is. Okay, which will be the final set that we're a part of. Okay. Next thing we have is we have our merge routine. And by the way, I should be stopping and verifying that some of this stuff works. I probably have typos in here that I'll have to debug in just a minute. But again, I just want you to see the basic idea here. Okay, so for our merge routine, we first of all need to figure out what are the 2 sets that x and y are a part of. So I'm going to call these sets A and B. And so A equals find x, and B equals find y. And then we will just say if A is equal to B, so if they're already in the same set, then we just return. There's nothing else to do, okay, if they're there. But if they're not in the same set, we need to figure out which one of those 2 sets is bigger. And so in this case, we're going to look at max size. So we will say if the max size of A is equal to the max size of B, Okay, in other words, if the two things are the same size, what we're going to do is we can just pick one, either one, it doesn't really matter which, and add it onto the second one. Okay, so what we're going to do in that case is, let's just say we're going to make B a part of A. So I'm going to set the parent of B is equal to A. So B is now pointing to A instead of pointing to itself. So it's B is no longer the root of a set. It's now going to be part of A. And A is going to get, the max size of A is going to get increased by 1. Okay, so it got a little bit bigger. Okay, otherwise they're not equal, so we need to figure out which one of the two is equal. So if max size of A is greater than max size of B, here I'll just do this as an else if. Then we'll do that, and then finally we will we'll have else, and this will be the final case, and that's if B is bigger than A. Okay, so if A is bigger than B, then we want B to point to A. So we set the parent of B equal to A. And we don't need to update the max size of A because it's already bigger, and so at most, we just added on one more than whatever the max size of B already was. And in this case, we just do the opposite, and we set P of A equal to B. And we're done. Okay, so that should merge things. So let's go ahead and test this out, see what typos I made. And evidently no typos at the moment, but let's try this out now along the way. So I'm going to run this. I'm going to say, let's say there's 10 elements to begin with. And just to demonstrate that this works, I want to find which set element 0 is a part of. Element 0 is in set 1. If I find the set that element 5 is in set 5. So everything is in its own set. And it should go all the way up to 9. And there's not going to be a 10. So 0 to 9. Okay, so let's say that we want to merge two things. Let's say that we want to merge 1 and 0. Okay, so we combined the element 1 and element 0 sets. And so now if I check what set 0 is a part of, it's in set 1, and element 1 is also in set 1. So they are now both in the same set. Element 0 and element 1 are in the same set. Whereas if I look at like element 2, it's still in its own set. Okay, and we can combine the same thing here. If I want to combine elements 2 and 3, and if I want to combine elements, let's say now 1 and 4. Okay, so remember I already combined 0 and 1. I've now combined 1 and 4. So 0, 1, and 4 should be in the same set. So let's just check that. I want to see which set 0 is in, and which set 1 is in, and which set 4 is in. They're all in set 1. And meanwhile, sets 2 and 3 are both in set 2. So that gives you an idea there of how those things can be combined. And now if I were to combine, say, 3 and 4 together, so if I do 3 and 4, now basically everything, all of those first 5 elements should all be in the same set. So if I look at 0, it's in set 2, and 1 is in set 2, 2 is in set 2, 3 is in set 2, and 4 is in set 2, and 5 is still in its own set. Okay, so the whole thing seems to work. Somehow I did not make a typo while I was doing it. It appears to be fine. And I can do 0 and end this. So that's the union find example. Again, I'll just look through the code one more time so you can see the different pieces of it. So we have a vector of P, that's the parent, vector of max size, maximum size. We can find our find routine just sets the it just checks to see if we're already at the root of the tree. So if the parent of x is equal to x, we return x. Otherwise, we're going to reset the parent of x so that it is whatever the result of the find is. So this is a recursive version. You can write this as a non-recursive version. You can write this basically every time you go up and look at a parent, just keep that in a vector and then use a while loop until you're at the base. And then at the end, go back through the vector and reset all of the things that you encountered along the way to the new base. Okay, meanwhile, the merge, remember you first have to find which set x and y are a part of. If they're the same, you don't do anything different. If they are not the same, you do have to merge them. And so if they're already the same size, you just pick one or the other. In this case, I'm going to have B point to A, and therefore the max size of A increases. Otherwise, if A is already larger than B, I can just add B onto it. Or if B is already larger than A, I can have A point to B. So those are them. Again, the initialization. When we initialize it, we have to set the parent of every element to itself and the max size to 1. And again, as I think we mentioned, you can, instead of using max size or max depth, you can instead use just the overall size and keep track of that, and that will work as well. And then finally, performing operations. That was just a read-in or testing framework. Okay, hopefully that was helpful to you.